Good morning, good afternoon, and good evening, everyone. I would like to welcome you all and thank everyone for joining the APRSAF online Stargazing event. My name is Hiroko Suzuki from the JAXA Space Education Center and also a secretariat for the APRSAF Space Education for All working group. I'll be your host for this event. This program is provided by the APRSAF Space Education for All working group, co-organized by the Australian Space Agency and JAXA in collaboration with the National Astronomical Observatory of Japan and other observatories. We have prepared this event as an opportunity for students to see and think about how the sky looks different in different parts of the world. Let me introduce today's program. We will start with opening remarks, and we will introduce the students' homework. After that, we will broadcast from 7 different observatories, and we will have closing remarks. You can use English captions for this event. If you would like to see the captions, please press the CC button. Live captions in another language are available by clicking the CC icon and selecting your language. If you have any questions, please press the Q&A icon and type your question. We will answer some of your questions during the Q&A session. We cannot type in the chat, so please only type your questions after pressing the Q&A icon. Now, we would like to ask Mr. Fumiaki Tanigaki for the opening speech. Mr. Tanigaki is a co-chair of the APRSAF Space Education for All working group and the director of the JAXA Space Education Center. Please welcome Mr. Fumiaki Tanigaki.
Hi, hello everyone. Thank you very much for joining this exciting educational programs. About 760 people have registered to participate in this event from Australia, Azerbaijan, Cambodia, Indonesia, Japan, Malaysia, Sri Lanka, Taiwan, Thailand, the United Kingdom, the United States of America, and Vietnam. This program is organized by many collaborators from space agencies and observatories in Australia, Azerbaijan, Japan, Sri Lanka, and Vietnam. I greatly appreciate their contributions and efforts to this program. Now, it's time to begin. Let's enjoy this exciting and wonderful and special event.
Thank you very much, Mr. Fumiaki Tanigaki. Now, we would like to ask Mr. Fumiaki Tanigaki for the opening. Sorry about that. Now, we will now introduce the summer homework. In preparation for this event, JAXA posted homework as an introduction to astronomy. We have provided 4 types of summer homework. We received wonderful sketches of summer triangle, original constellations, old and new constellations. Now, I'll show you some of them. This is one of the summer triangle sketches we received. I apologize if I pronounce student's name and also the presentator's name wrong, but this sketch is drawn by Hansadi. And next, I'll show you the student's original constellation by Haruki Nakajima. Here's his original stories for this constellation. Once upon a time, there was an elementary school which the God's children enjoyed going to. One day, it rained so hard that it turned into a flood, and the school sank to the bottom of the river. And the gods were so depressed by this and turned the children's dreams, friends, and teachers into stars. So this is the story of the elementary school constellation that he thought of. Next, I'll show you the other original constellation by Gobindu Arahaku raccoon. This is a story about the royal dog named Leo who protected his family from dangerous situations, and God placed him up in the sky. Leo, the loyal, symbolized bravery, loyalty, and conditional love that God brings to our lives. The left image is drawn by Chisa Yamada. It's an old constellation. It is a drinking cup constellation, which is the Orion constellation we now know. And we have an image of Taurus on the right drawn by Mayano Iwamoto. We have received many more homework submissions. Thank you very much for submitting them. We enjoy reading them all. Thank you very much. Now, we will go to broadcasting part. Have you ever wondered what the stars look like from other parts of the world? The stars and constellations appear in the sky differently depending on the latitude and the longitude or the time difference. In this event, we will broadcast from 7 observatories. We planned to broadcast from Canberra, but unfortunately, we canceled it. We will broadcast from Hawaii in the United States of America, Jinjin in Australia, Tokyo in Japan, Okinawa in Japan, Natan in Vietnam, Baku in Azerbaijan, and last but not least, the Moratoa in Sri Lanka. First, we will go to Hawaii. We will see the live stream from the Subaru Asahi Star camera. This camera is set at the Subaru telescope on the mountain of Mauna Kea in Hawaii. Now, I'll try to show the sky. Good evening, Dr. Yamaoka. Are you there?
Hi, can you hear
Hi.
me?
Yes, I can hear you. Okay.
Yeah,
Yeah. What time is it in Hawaii now?
in Hawaii, now 2 a.m. and 8. So very deep night.
Yes, pretty night. And what can we see in Hawaii?
We can see with our live camera on the top of the Mauna Kea Subaru telescope. So this camera shoot the eastern sky. So now the winter constellation will appear. Please show the live camera. This is top of Mauna Kea. There are many observatory domes which contains very, very big telescopes. And you can find several constellations, winter constellations. The most famous one is constellation Orion. Please point. 1, 2, 3, 4 stars and 3 stars within them. That is constellation Orion. In the movie, which explain the star chart of Hawaii native, this constellation Orion will appear. So please proceed.
Now, we will have Dr. Kumiko Usuda Sato explain the star line in Hawaii and Hawaiian stories within the sky. Now, we will see the video.
Aloha! My name is Kumiko Usuda Sato. I am a Japanese astronomer working at Subaru Telescope, Hawaii. I would like to introduce Hawaiian star lines. A long time ago, Polynesian people, the ancestor of native Hawaiians, came to the Hawaiian Islands with a canoe. This is a modern canoe named Hokulea and similar to an ancient one. They use wayfinding techniques such as navigation by the stars and observations of birds, ocean swells, and wind patterns to know where they were in the ocean. and where they went. Today in Hawaii, the 4 star lines were created by connecting star to star as a practical device for reading the night sky by modern Hawaiian wayfinders. The winter, spring, summer, and fall star lines are much bigger than ordinary constellations. Tonight, through the Subaru Asahi Star camera at the Subaru Telescope facility on Mauna Kea, Hawaii, you must have observed the Orion constellation. Its Hawaiian name is Kaheihei Onakeiki. You may also have seen the Pleiades. Its Hawaiian name is Makali'i. Makali'i is a young star cluster, and its Japanese name is Subaru. Our Subaru telescope is named after Makali'i. The name of the winter star line is Kekao Makali'i, the Vela of Makali'i. Kekao Makali'i starts from Capella in the Auriga constellation to Castor and Pollux in the Gemini constellation, Procyon in Canis Minor, Sirius in Canis Major, that is the brightest star in the night sky, and ends at Canopus in Carina constellation, that is the second brightest star in the night sky. The shape of the star line resembles the shape of a canoe bailer. Wayfinders or navigators memorize the star lines and voyaged without instrument. The Kekao Makali'i star line is based on a legend in Kona on the island of Hawaii. A long time ago, in the village of Kona, a mean chief lived, and his name was Makali'i. He took all the food in the land from his people and animals. He collected everything in a net and violently threw it into the sky. The net got caught and hung stuck on the cluster of stars. The people and animals became hungry and thirsty. At that time, a rat said, "I will get our food back." The tiny rat climbed up to the tallest mountain and then jumped onto a rainbow. He climbed higher and higher and reached the net. Soon after, he started to nibble the bottom of the net. Food fell onto all over the land like the rain. The rat also fell with the food and landed on a rock in Kalae, the most southern part of the island of Hawaii. And the star cluster was named after the mean chief, Makali'i. Tonight, I introduced the winter star line for Hawaiian wayfinding. If you are interested in, please check the other 3 star lines at the Imiloa website. You can also enjoy Planetarium Show. That's a short film of cultural and indigenous astronomy from 7 different countries and regions, including Hawaii. These films were created by the One Sky Project, an international collaboration of Imiloa, the 30-meter telescope, and other organizations. On the website, anyone can watch the film for free. This image in this film shows the Hawaiian summer star line, Manaya Kalani, the fish hook of Maui, and Calpea Cabello, the kite of Cabello. I hope you enjoy my story and see you again. Mahalo nui loa. Ahui ho. Thank you very much. See you again.
Hi. Now, Hiroko-san.
Now, thank you very much, Dr. Usuda Sato and Dr. Yamaoka. Everyone, if you have questions, please press the Q&A icon and type your questions. Okay, I'll select some of the questions. So how to join? I received a question about the homework, how to join with these activities and homework. So we have a website, and you can see our 4 types of homework, and you can go outside and watch stars. But we finished, the registration for submitting is finished, but it will be nice to go do the sketches of the constellations. So I hope you try it. Thank you. Thank you for asking. Don't have other questions right now. Thank you very much, Dr. Yamaoka.
Thank you.
Thank
See
you.
you later.
Thank you. See you later. Next, we will go to Jinjin in West Australia. Mr. Rick Tornado is at the Gravity Discovery Center Observatory. Good evening, Mr. Rick Tornado.
Good evening, everyone. Hope everyone is well.
Could you tell us what time it is and how is the weather in your area?
It's currently 19 minutes past 8 in the evening here in Western Australia. And unfortunately, our skies are not covered in cloud. They are covered in smoke. We have a very big fire to the south of us that's producing a lot of smoke. And unfortunately, it's covered up our beautiful night sky. So I will have to show you pictures instead, which I'm a bit disappointed. But nevertheless, I do want to share with you a quick image to start off with of our observatory that we have here. And we should be seeing a live image of our observatory. And in just a few moments, we're going to be getting some people coming in to do a tour of our observatory. But while I want to keep going on, is I do want to tell you a story about our night sky from what we can see here. So I will share my screen with everyone. Oops, let me just try this again. Here we go. Go to this one here and share that one there. There we are. Let's try that. There we go. This should be working now. And I'll start my little presentation. So what we've got here, we should be seeing a picture of what I can see if there's no smoke. So I can see from the southern sky, I can see a lot of stars that are normally you cannot see from the northern hemisphere. But the ones I do want to point out are the ones here, the Southern Cross and the 2 pointers, because what we have is the 2 pointers because you draw a line between the two and it points at the top of the Southern Cross. But for a bit more of a zoomed up image, this is what we would see. We would see, of course, the Southern Cross over here and the 2 pointers. And if there was no smoke, we could see the Large Magellanic Cloud and the Small Magellanic Cloud, which are 2 satellite galaxies of the Milky Way galaxy. But one of our targets would have been Alpha Centauri. The other one would have been Omega Centauri. And also I wanted to show you the Southern Cross, and also within the Southern Cross, the spectacular jewel box. But I do want to point out some traditional stories from the Nyungar people, the traditional caretakers of the southwest of Western Australia. And they had some shapes in the sky, constellations. And in fact, these are the shapes from the first astronomers because their stories date back 65,000 years. So this picture here shows us, well, we see the Southern Cross right there and the 2 pointers and the Milky Way stretching down here. But the Nyungar people saw 2 of their spirit animals in the night sky, which is a part of an ancient story called the Carers of Everything. Now, the first character I want to show you is very familiar. It goes by the name of Yonga. And Yonga is Nyungar for kangaroo. And this is Yonga the kangaroo right here. Oops. There we go. Oops. There we go. Let's try that again. Seems to have jumped around a bit. Here we go. And here is Yonga the kangaroo right there. So Yonga is made up of the Southern Cross. There's the kangaroo's head and the ears. The 2 pointers are the front paws, the backbone. Scorpius down here forms the tail. There's his foot. In amongst all that is Waich the emu. Now, the emu is made up of all the dark dust lanes of the Milky Way galaxy. And Waich looks like this. There's Waich right there. So Waich is a troublesome character, and he got a bit angry. He thought he was tricked to jumping up into the night sky by the spirit woman. And he got so angry he started to attack her. But the kangaroo, who was also up there, jumped onto the emu's back and stopped him from attacking the spirit woman. But this is a very ancient story, and it goes on for a very long time, so I won't tell all of it. But I do want to point out some of the things, especially the Southern Cross. Now, the Southern Cross here is the smallest of the 88 constellations recognized by the International Astronomical Union. And not only can we see it up in space, but we can also see it on the flag of Australia, flag of New Zealand, a number of Pacific Island nations, and if you look very carefully, we can also see it on the flag of Brazil. But of course, when we look at the Southern Cross here, we see 5 very bright stars. We see Alpha Crucis, Beta Crucis, Gamma Crucis, Delta Crucis, and little Epsilon Crucis here. Now, these are quite far away stars, but they do, even though they're far away from one another, for us, it does appear to look like a cross on its side. But within here, in fact, just off Beta Crucis, right about there, let's just highlight that little spot there, is the magnificent jewel box cluster. Now, the jewel box cluster really lives up to its name. Now, this is a picture that I took a couple of nights ago when the sky was clear, and this is the jewel box itself. Now, the jewel box is known as an open cluster. It contains about 100 stars, and they're somewhere between 10 to 14 million years old. So they're still quite a young cluster. Now, this one particular star I want to point out, and it's called the jewel box because it has different colored stars. And this one right here happens to be a red supergiant star. That is DU Crucis. Now, DU Crucis is a red supergiant star that is very, very big. In fact, it's 664 times bigger than our sun and is nearly 70,000 times brighter than our sun. So this is a very big, bright star. And even though it's so young, it looks like it's going to explode in a couple of million years in something called a supernova. Now, I do want to show you a couple of other targets that are around that particular area, around the Southern Cross. So, of course, back to our picture here, we have the Southern Cross, we have the 2 pointers, but I do want to point out a few other things. Alpha Centauri and Omega Centauri. Now, we'll start off with Alpha Centauri. Unfortunately, I do not have a photo of Alpha Centauri. Originally, that was going to be my colleague from over in Canberra, Brad Tucker, but he's a bit sick tonight. But Alpha Centauri is one of the closest star systems to our solar system. It's only 4.3 light years away, which means when we see the light from Alpha Centauri, it has taken 4.3 years for the light to travel at the speed of light from that star to us. Now, it's made up of 3 stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Now, Alpha Centauri A and B are very similar to our sun. Alpha Centauri A is slightly bigger, brighter, and hotter than our sun. Alpha Centauri B is slightly smaller, cooler, and dimmer than our sun. Now, Proxima Centauri is actually very, very small. It's a small red dwarf star. So it's very small and very faint, and we can't see it very well through our telescope. But just the same, it is still there, but it does have a planet around it. Let's move on to Omega Centauri. Now, before we proceed on, I want to tell everyone a very basic fact, and especially looking at this picture here. So the 2 facts that I've learned from a very young age are, 1, stars are suns, but very far away. And the second thing I want to tell you is our sun is a star, but close up. So this next picture here hopefully will impress you because this is the mighty Omega Centauri. And here it is here. Omega Centauri is called a globular cluster. That is because it is a big ball of stars. It contains around 10 million stars. In fact, it is the biggest globular cluster that we know of. And it's only, well, it's not too far away. It's only about just a little under 16,000 light years away. But when you look at this picture, you are seeing each point of light is a sun, a mighty sun. So, like I said, there's about 10 million stars, 10 million suns packed into this ball. It's about 12 billion years old, we reckon. And it's probably the remains, it's the core, the remains of a dwarf galaxy that was chewed up and spat out by the Milky Way galaxy. So it had all its outer stars ripped away from it, and all that remains is this big ball of 10 million suns. And there we are. That's it from me. If we have any questions, don't forget to type it into the Q&A, and I would gladly answer the questions from the Southern Sky.
Thank you very much, Rick. we see many questions right now. The first question I want to point out is that why can't we see the southern constellation in northern hemisphere? So he wants to know why we can't see the southern constellation in northern hemisphere.
Okay, so am I still on?
Yes.
Okay, so we can't see this. So from people in the northern hemisphere can't see the Southern Cross because, well, the Earth is round. It's a ball, and you are on. Well, you can't see past the curve. So if you're standing in the northern hemisphere and you look south, well, you can't see it. But if you keep walking south, and as you go over the equator, then you start to see what looks like over a hill. Oh, look, we've got some guests coming in. So you start to walk over a hill and you start to see more what's over the hill because remember, the Earth is curved. So that's why you can't see, and I can't see, say, something like the North Star or constellations like Cassiopeia. So because of the curve of the Earth.
Thank you for answering. And the next question is, why do we see the southern constellation upside down from the northern hemisphere, northern constellation? The constellation we can see in northern hemisphere.
Okay, well, it's not upside down for us, and I suppose it is. But so what it is because, well, here in Australia, a lot of people say Australia is down under. So if you imagine having a basketball or a ball in front of you, and at the top someone is standing up on the North Pole, but underneath at the South Pole, it looks like that person is standing upside down. Okay, so from their perspective, if they were to look out at, say, a constellation, the people in the south would see it upside down compared to the people in the north. So for us, when we look at the constellation of Orion the Hunter, we see it the wrong way around. It looks like Orion is standing on his head. But we've gotten so used to it that when we travel up north and we see it the right way up, it gets a little bit confusing for us, and we have to think a little bit to think of what we're actually looking at.
Thank you very much for answering. I think there are many students who live in the northern hemisphere, so they wanted to know about that. Okay, the next question is Omega Centauri an individual star or globular cluster?
Omega Centauri is a globular cluster. It contains 10 billion stars. So it's a big ball of stars all bunched together, and gravity holds them all together.
And next question is, how many stars are in the universe?
Oh, that's a good question. I love this question. So from current estimates, how many stars are in the observable universe, that's the universe we can see, we reckon it's around 300 sextillion stars, or 300 with 21 zeros after it. So that's how much we reckon, because we look at galaxies and we look how bright they are, and we can estimate how many stars are in each galaxy. And of course, astronomers have mapped out over some 2 trillion galaxies in the observable universe. So we can estimate there's around 300 sextillion stars in the observable universe.
Okay, the next question is written in English, in Japanese, but so why doesn't the kangaroo constellation have a the part of the stomach? So
okay. Why doesn't it have like the pouch and the yeah. Okay. Well, that's a good question. I didn't make it up. I'll have to talk to my friend, Dr. Noel Nanup. Now, Dr. Noel, he is a Nyunga elder, and I will have to ask him that. I do not know the answer to that, but I think the way it is drawn in the sky, there is that picture of Yonga the kangaroo and Wage the emu. So I think his stomach, or Yonga's stomach, might be squashed in, but I don't know. I'll have to ask Noel.
Thank you very much. We have many questions, so I hope you can type the questions online. Thank you very much.
My pleasure. Thank you.
Yeah. Then I'll go to next observatory. Now, we will go to Tokyo, Japan. National Astronomical Observatory of Japan is located at Mitaka in Tokyo.
Okay.
And Dr. Hitoshi Yamaoka and his staff members at this observatory and using this telescope. Good evening, Dr. Yamaoka. Again.
Hi, hello again, Hiroko,
again.
and everyone.
What time is it in Mitaka?
Behind me, 50 centimeter telescope, and the weather of Mitaka is very fine, so we can see the stars and objects with our telescope for live show.
So, how's the weather in Tokyo now? Is it great?
Very fine.
Very fine. Good to know. So, what can we see in the sky today?
Yes, now moon is very bright in the eastern sky, but over our head there is three stars making a triangle, which is called as summer triangle. Please show that. Yes, there. It is near the top of our sky. The brightest star is westmost one amongst these three stars. The name of this star is Vega. Yes. Alpha Lyrae, and the Japanese name is Orihimeboshi. It is one of the brightest stars in the northern sky, and we can see it through our telescope. Please show the real image. Yes, the right side, the star is shown. It is Vega. Vega is its brightness is 0.0 magnitude. Brightest one of three stars in summer triangle.
It's very bright and shining beautiful.
Yes. In Japan, there is a legend about this star and three summer triangle stars. The Orihime is a very hardworking girl, and the Heaven Emperor loves her work, and Heaven Emperor choose the other hardworking boy called Hikoboshi, married with Orihime. Hikoboshi and Orihime are very pleased, but they forget to work. So Heaven Emperor decide to separate them on different side of the Milky Way, the river of the summer sky. And only once in a year, Orihime and Hikoboshi can meet. It is a night of Tanabata.
So it's a Tanabata story.
Yes.
And they only can meet once a year. That's a pity thing.
Yes.
Yeah.
Okay. This is the first object we like to show, and I move to second object. So please show the slide. Yes. Second star is Albireo, Beta Cygni. Constellation Cygnus is located between Orihime and Hikoboshi. The shape of the constellation Cygnus is large cross. It is called as Northern Cross, in contrast with Southern Cross, which shown from Australia. The Northern Cross, Albireo is longest arm of the cross, and we can shoot this star with our telescope. Please change to the real image. Yes, this is Albireo, the double star. You can see the bright star as orange, and dimmer star is blue. It shows the temperature of the star. The bluer one is hotter than the orange one. These two stars appears in the literature, 銀河鉄道の夜, the night train of the Milky Way, written by Kenji Miyazawa. It appears as a signal point of Albedo. That is very famous and beautiful double star. Okay. Have you enjoyed our star?
Yes, I enjoy watching it. Yeah, they're very beautiful. Yeah. Yeah. And now, we will go to the Q&A section. So we've received many questions. The first question is that, why does the star shine like bigger?
Yes. The stars star shines like a bigger and like our sun. The such star generates energy in the center of them using the nuclear energy. And they can shine very long time, like billion years or more.
Thank you very much for answering. The next question is, so he's saying that he is 7 years old and he lives in Japan. And the question he has is, who is behind you? I see a person moving behind you.
Our staff operating telescope, and sometimes he or she appear out of my backward.
Yeah. So, hello. So they are trying to operate the telescope. Thank you very much. Next, I'll go on to next section. Next question. What is the actual color of the sun?
Actual color. The sun is very bright, so we cannot see it directly. But if you split the light from the sun, you can see every color of from the sunlight. You can see the rainbow color from the sunlight. But the mixture of such colors, the sun looks like white or slightly yellow. But if the star has a surface temperature lower than the sun, the color of that star is orange or red. And if the surface temperature of the star is hotter than our sun, it shows white or blue.
I think our Q&A time is up. Thank you, Dr. Yamaoka, for answering your questions. Thank you very much, and your staff members. Thank you. And everyone, please push the reaction button to thank the Dr. Yamaoka and his staff members. And last time I didn't tell you to put the reaction button for Rick, so please push the reaction button for Rick to thank them. Thank you. Now I'll go to next observatory. Now we will go to Ishigatijima, Japan. Good evening, Dr. Natsuki Hayatsu. Are you there?
Yes, good evening.
Could you tell us where you are and what time it is in your area?
Yes, hi everyone. I am at Ishigatijima Astronomical Observatory and it is 9:44 at night.
So it's good time to watch stars.
Yes. So do you want to know the weather?
Yes. How is the weather in Ishigatijima?
So let's check together. Let me share the live video. So the image shows the yes, Yeah. So here you see the current stars and sky seen from our observatory.
Mhm.
So weather is not very good. It's raining and very unstable. A few minutes ago, it was totally cloudy. But don't worry, we have taken videos in advance. So then let's switch to my presentation. So the image shows the star chart for Ishigaki Island. So then we are going to see 2 or 3 objects. So Delphinus Gamma, this one, the center one, and Antares, and Moon Crater. So, but before we start stargazing, may I briefly explain our observatory?
Yes, please.
Yeah. Okay, thank
Course.
you very much. So, can you see the video?
Yes, I can see the videos.
Okay, great. Thank
They're
you.
beautiful.
So, yes, the video in the background shows our Ishigaki-jima Astronomical Observatory. So, at the beautiful summer night sky, it's in lovely. And you might think the name of the observatory is a bit long to remember, so feel free to use our handy acronym, ISHAST. So Ishigaki Island is a small island, but there actually are 2 NAOJ, National Astronomical Observatory Japan facilities. The first is Bella Ishigaki Station, a radio telescope built in 2002 with a 20-meter dish. The second is our ISHAST. We have the largest optical telescope in the Kyushu Okinawa region, a 105 centimeter reflecting telescope, so which we use for both educational and research purposes, and now we'll be using it. So my message is, please make sure to visit us at least once in your lifetime, and don't forget to check out both Bella and ISHAST. So let's see the stars. So we are providing the videos taken by camera attached to the telescope. And first, we are seeing Gamma Delphinus. The star is located on the dolphin's head in the constellation Delphinus. So with a naked eye, it actually looks like one star, but you can see 2 stars with the telescope. The constellation Delphinus is a minor constellation with many dark stars, so you cannot see a bright region like Tokyo. But it is a summer constellation and has double stars like this in beautiful color combinations. So the brighter star is 4th magnitude, and the color is light orange. And the fainter star is 5th magnitude, and the color is white. Then they are thought to be a binary star with a period of about 3,000 years, and the distance is about 110 light years. So, okay, so the next, so the Antares. So you may know it is located in the constellation Scorpius. So it is a very bright star, and it's easy to spot in the night sky. So you can easily find it. So it has a different name in this region. It is called Iyucha-bushi in local dialect. Iyucha-bushi. So the meaning is fishing star because the shape of this constellation looks like fish hook dropped into the Milky Way, the river in the sky. So Antares is a huge star called supergiant. So if Antares were where the sun is, it would reach all the way past the orbit of Mercury, Venus, Earth, and even Mars. It's really surprising, right? And it is about 600 light years away. So the last. So I quickly show you the moon crater. So there are 2 craters at the center of the video, the center of the video, 2 craters, 2 big craters, and they are touching each other, right? And near the point where the 2, you may see my cursor. So near the point where the 2 circles meet, there is actually small crater about 300 meters wide. It cannot resolve by the telescope, but this is where the slim spacecraft, the Japanese lunar lander, is landed this year. It's really, nice achievement. for us. Then, so using the rest of time, let me introduce about the name of our telescope, Murikabushi. Murikabushi is a local dialect name of the Pleiades star cluster, also known as Subaru in Japan. And what was the name of the Hawaiian? We learned. I forgot, but it was named by Ishigaki citizens. And why Ishigaki citizens named the telescope Murikabushi? Because this star cluster has been special to the people of this region for a long time. So long time ago, people in this region used star viewing stone. So this one, Hoshimiseki in Japanese, to determine the season for farming. The exact method is unclear, but it's believed that they observed the stone from specific angles, placing their hand on the ground and at a specific time, for example, just after sunset, then they observed stars beyond the stone. So this helped them decide when to plant and when to harvest. So one of these important stars was Murikabushi, because it is really easy to find in the sky. So Murikabushi is a symbol of this unique astronomy-related culture in this region. So today, the name is still used for our Murikabushi telescope here at ISHAST. So I forget to show this movie. And that's it from me.
Oh, it's moving. It looks good.
By the way, Hiroko-san,
Mhm.
can you find Murikabushi in the background image?
I can, yeah. Yes, I
You
can
can?
see it. Yeah, I can see that. Cute. So, yeah,
This
there.
one, right?
Yeah, that
There.
one. Yay.
Okay, that's it.
Thank you very much for explaining that. We received many, many questions. So I want to
Great.
ask you questions. So you you introduced about the swim. Thank you very much. So I chose this one. Why are the rabbits in our moon? Why is the rabbits why is a rabbit in our moon? So in Japan, we say that there is a rabbit in the moon.
Mm-hmm.
Mm-hmm.
Why is a rabbit?
Rabbit is in the moon.
Yeah, I know the people in different place guess the pattern of the moon. So and in Japanese case it's rabbit. And what was the question? Sorry.
So I'll say it precisely. Why is a rabbit in our room? So this is her question.
Why?
I think you answered the question. So in Japan, we see the moon as like a moon's crater as a rabbit, but you'll be different. You'll be different character or different saying in other countries.
Yes.
Yeah.
Because so from the southern hemisphere, it's the how to say the pattern would be the opposite. So maybe we can guess different picture. So yes, this is one thing.
Mm-hmm.
And so precisely the picture we guess is rabbit making the rice cake, right? So rice cake is very Japanese food, right? So yes. Sorry, I'm not sure the exact answer.
Thank you very much.
This is just my opinion.
The next question we have is there alien out there?
Is there alien out there? I guess so, because currently many astronomers find the Earth-like object. So in the outside of the solar system. So this is related to the question how we are special, right? But I guess yes, how human or living things are special in the universe. But I guess we are not special. There are many there are many Earth-like planets, then probably there are aliens, the living things in the outside of the solar system. This is also my opinion. Yeah.
Thank you very much for answering.
Yes. There is no exact answer, I guess. But we are seriously trying to find the alien, the signature of the living things.
Okay, I'll go to next question. Are there stars with the same gravity as Earth?
Yes, stars is the same gravity as Earth. Same gravity. I guess I can say yes, because the mass of the if the mass of the Earth is and the size of the Earth, the planet is the same. It should be it should have the same gravity.
And next question is, how are craters made?
How are craters?
The moon crater or any kind of crater?
The crater, why crater is formed? You mean there is an impact of the big meteoroid. So then yes, so it becomes a crater. Am I answering the question?
You answered the question.
Yes.
Thank you very much. Okay, we have many more questions, but we have to stop right there.
Okay. Thank you very much.
Thank you very much. I'll go to next observatory. But before that, everyone, please push your reaction button to thank Dr. Hayatsu.
Okay. Thank you very much.
Here's a heart. Here. Oh, thank you. Now we see many hearts and claps.
Thank you.
And happy faces. Thank you very much. Now we will go to next observatory. Now we will go to Nha Trang, Vietnam. Dr. Nguyen Thi Thao is there.
Yes.
Good evening, Thao-san.
Hi, everyone. Hi, beautiful.
Hello, how are you doing? Could you tell us where you are and what time is it in your area?
I'm right inside the Ornata Observatory right now. And now it's near 8 p.m. in Vietnam. Can you hear me?
Yes, I can hear you. I think everyone can hear you now. Yeah, and I see the slide.
So maybe let me introduce you to my observatory. This is Nha Trang Observatory, located at 12 degrees north and 109 degrees east. As you can see in the picture, we are close to the sea. And inside the observatory, there is a 50 centimeter telescope, and now it's behind me. So this is the second largest telescope in Vietnam. And additional to research activities, we regularly organize themes and astronomy observation events in our observatory. And we also take many beautiful photos in order to raise community interest in astronomy. Here you see the Orion Nebula. It is a map of a newborn star, and it's very bright in the sky. But you can see now in Hawaii telescope. And this is the end of a star similar to our sun. And what you see is the remnant of the star. This picture taken from our telescope, and also it's the Lagoon Nebula that you can see in the sky in Vietnam right now. This is there are dark lamp and a new star being born at its core, and make it easier visible through binoculars or a small telescope. And I have checked the weather in Vietnam, and it's cloudy because we have a big storm approaching. I hope it doesn't reach the area. So if the weather good, we can see the sky like this, and we will see an arrangement of six stars in the south and east sky. And the old Vietnamese also recognize this star as and imagine the shape of a god back. And imagine that he recently have it right in the selection field. This rock is unknown and means deity of family. So about this star, there are three stars come together to create a pattern. Recently, a half unknown serves as a signal for time to harvest rice and other crops. And as in Japanese culture, we share the same story. But approximately 3,500 years ago, the Greeks added five more stars at this arrangement, forming the tail of a scorpion that extends from the back of the nose. And in 1920, this star cluster officially became known as the constellation Scorpio. Near Scorpio, let me show you Antares, the very bright red star at the head of Scorpio, well known in Vietnam as the beloved star, corresponds to Antares, as you mentioned before. This star is referenced in Nguyễn Du classic poem, Thiện Kiều, the Turn of Thiện Kiều, with the line, the star tree can say the star first. Would I have thanked you so much for her part? The star tree refer to orange bells in our time. For Vietnamese, orange bells and Scorpio are nearly 180 degrees apart, one rise as the other set, symbolizing separation, as they never meet. So, near Scorpio, there's a group of six stars forming a dipper-like set facing the Big Dipper in the north. This pattern is called the Southern Dipper and is linked to a deity Nam Tao. In our belief, Big Dipper corresponds to the deity Bắc Đầu. Nam Tao and Bắc Đầu are considered guardians of human life and death on the earth. Today, this six bright star belongs to Sagittarius constellation, one of the zodiac constellations. And then there are very famous luminous streets like this, which you can see in the Dachshund line. And our solar system is located in a galaxy known in Vietnamese as a river of stars flow across the sky. And you are looking at it right now. So, according to a folklore, this lunar river divided two lovers, Giga, who known as the Wave Girl, and Ante, the Cowhead. In Vietnam, they are collectively referred to as a no couple. Legend says they are allowed to meet only once a year when gathered from a bridge. And when they have to part, the tear falls to earth as rain, known as no rain, often happening in September in Britain. That's why we have a sky cloudy today. But today, this bright star forms part of an imagined triangle called the summer triangle. And Venus is the third star, and it is in the single constellation together with this star. You can see that it's visible in the night sky during summer. That was a short introduction about the sky in Vietnam. So thank you very much. So if you have any questions, please type in Q&A.
Yes, thank you very much, Tao-san. Okay, we have many questions, so I'll ask you questions. So the first question is, how do people find the side of the object in the universe? How do people find the side of the object in the universe?
So would be the people find the side of the object in the universe. So maybe as I understand that you asked about the size of universe, right? So first, descend the telescope to the space, and from the space we look at the sky in every direction. And in some place we see that a very large galaxy and a new star morning. It starts from here around 13 or 14 million years away. And use Doppler effect when the thing is very far from you. you will see that the sound is very low. Then we know the size of the universe.
Thank you.
I will exercise you to answer the answer.
Thank you very much. Yeah. And I see the telescope on your back, and I have a question about the telescope. So her question is, how far can you see with that telescope?
This one it depends, but you can see the object at 1.4 billion years away from Earth. But it depends much on the light pollution, the surrounding area.
How's the situation? How's the light pollution situation in Vietnam?
It increased day by day because in that time now it's a tourist city and everybody wants to turn on the light until 10 p.m. After 10 p.m., then you can work again. But before 10 p.m., it's impossible because the light is on the boat, on the sea, and the light from the city, the light from the human activity everywhere, every direction. But after 10 p.m., the sky is quiet and they turn off the light, and then we start work from 10 to about 4 a.m. We have 6 hours every night.
Okay. And the next question I have is, it's quite different type of question. Why does human beings are trying to reach Mars? Why are human beings trying to reach Mars?
So why human beings try to reach Mars? Why they don't come to Venus or the moon? But in fact, Venus is very bright and very close to humans because there is acid now on Venus. We cannot live there. But Mars is far from the Earth, far from the sun, even more farther than the Earth. And it seems that we found some water and some and we try to find the habitat zone for humans. But first people already land on the moon, and the second target we will go to Mars, the nearest object to the Earth.
Okay, next question is, what is black hole? What is black hole?
Yes, the black hole. But what is the question about the black hole?
So he's asking, what is black hole? What actually is black hole? What is black hole?
No one knows. But in 1972, there's a physicist called the object black hole because nothing can escape from it. So nothing can escape because of gravity. The gravity is so strong that even light cannot escape from the black hole. Recently, human beings observed the black hole in Messier 87. That is the first black hole we observed in radio frequency. But long time, 30 years ago, we already know that in Milky Way, at the center of Milky Way, there is a black hole. But we see the movement of stars and objects around the black hole. And the reason that we can see the black hole because we see the horizon of the black hole where the material tear in two parts. One fall down in the black hole and one go outside the black hole, and it produces photons, very high energy photons. That's why we can see black hole at the horizon, at each horizon. So am I answering the question?
Yes, you did. Thank you very much. I think our time is up. Thank you very much, Dr. Tao-san. Tao-san, thank you very much. Everyone, please push the reaction button to thank Tao-san. Thank you very much.
Thank you.
Thank you. Now I see many hearts. Now we will go to next observatory. Now we will go to Baku, Azerbaijan. Dr. Kamera Arshiva is there. And good evening, Dr. Kamera Arshiva.
Good evening. I greet you from Baku, Azerbaijan. I am broadcasting from Baku State University. Now it's daytime.
What time is it now?
5:15 p.m. now in Azerbaijan.
So it's not. So you cannot see stars at this time.
Yes, we cannot see star, but I will show with star chart. Currently, during my presentation, the sky over Baku look like this. The sun is setting towards the western horizon. At the zenith, the constellation Hercules is visible, with Draco, Corona Borealis, Serpens, and Ophiuchus along the meridian. East of the meridian, Lyra, Cygnus, Scutum, Delphanus, Ecola, and Lacerta can be observed. On the horizon, the newly risen constellation Capricornus and Pegasus are visible. To the west of the meridian, Ursa Major, Bootes, and Libra are visible. The sun is in Virgo. Constellations setting on the horizon are part of Leo and Virgo. Additionally, Mercury is located near the sun in the west and the Venus in the east. However, after sunset, throughout the night, the constellation Draco, Cepheus, Cassiopeia, Andromeda, Pegasus, Ursa Major, Ursa Minor, and Cygnus will be visible. From the zodiacal constellation, Aries and Pisces will be visible all night. Aquarius and Capricornus in the first half of the night, and Taurus and Gemini in the second half. Along with the star, Saturn and 17.7-day-old moon will be also visible throughout the night. Throughout the night, the Triangulum galaxy and Andromeda galaxy will be observed through the telescope. Now, I want to show my next presentation. From a very young age, people have gazed at the sky and never tired of marveling at the wonder of the space. Ancient Sumerians are already distinguishing 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, from stars and observing them. Ancient Egyptians and Greeks grouped the stars into constellations and named them after various mythical creatures. Many of current names of the constellation have been inherited from them. As the science of astronomy advanced around the world, Azerbaijan, situated at the crossroads of Europe and Asia, was also part of this process. The medieval monument, Maiden Tower, is in the capital city of Baku, served as one of the initial observatory for many scholars. The tower's windows, buttresses, and other elements were decising to align with the sun direction on specific day, equinoxes, and solstices. From this window, constellations such as Lyra and Taurus and Sirius could be observed. In the 13th century, the renowned Azerbaijani astronomer Nasreddin Al-Tusi constructed the famous Maraga Observatory, which made a significant contribution to the field of astronomy. Notably, a celestial globe made by him is preserved in a museum in Dresden, Germany. Shamakhë Astrophysical Observatory has established in 1960 at the foot of Mount Pirkuli, situated 140 kilometers from capital Baku city. Thanks to initiative of Azerbaijan's great leader Heydar Aliyev, the astrophysics department was established in 1975 at Baku State University. This university is Azerbaijan's first university, which is celebrating its 105th anniversary this year. Many countries still do not have any observatory, but Azerbaijan built a second one at an altitude of 2,050 meters above sea level in Batabat in 2003. These observatories conducted photometric and spectroscopic observation of the sun, stars, planets, and other celestial objects. It is a significant achievement for Azerbaijan that some of celestial bodies were named with Azerbaijan relative names. By the International Astronomical Union's decision, the names of famous individuals from each country are given for celestial bodies. Name can be not only given to astronomers, but also to writers, composers, sculptors, and others. On the moon, the closest celestial body of Earth, one of its numerous craters, has been named after Nasruddin al-Tusi. Additionally, the asteroid Tusi is also named in honor of the great Nasruddin. On the moon, one of the craters has been named after Nadir Ibrahimov, who made valuable contribution to study of Mars. Nadir Ibrahimov is a staff of the Shamaha Astrophysical Observatory, who took over 2,000 images of Mars. Another crater on Mars is named Guba, which is one of the most beautiful regions in Azerbaijan. The Mercury, the hottest planet in the solar system. The name of the world-famous medieval writer Nizami Ganjavi has been immortalized. Asteroids or small bodies of solar system were initially named after heroes from Greek mythology. Later, however, asteroids with precisely calculated orbit began to be named after famous individuals from various countries. The asteroid Azerbaijan discovered in 1971, the asteroid Nizami discovered in 1978 and named after the famous writer Nizami Ganjavi, and the asteroid Magamayev discovered in 1974. Asteroid Javid discovered in 1978 is named after the famous Azerbaijan poet and playwright Hüseyin Javid. In 2007, the former director of the Shamaha Astrophysical Observatory, Professor Ayub Guliyev, had the asteroid Ayub named in his honor. In additionally, the scholar students at our university have formed an amateur astronomers club and conduct photometric observation with the Schmidt-Cassegrain telescope at the Baku State University Students Scientific and Technical Creativity Center. The technical parameters of this telescope are the following. On this photo, you can see our students when they observe the sun. On this image, you can see the nebula Eskimo, global cluster, surface of the moon. All of these images were taken by our students and amateur astronomers. On this slide, the nebula Eagle and nebula Trifid were taken by our astronomer, Dr. Mikhail Khadyrov. Thank you for your attention.
Thank you very much, Tamara, for explaining about it. Now we know about astronomy in Azerbaijan. We have received many questions.
Welcome. I have answered some of questions in the chat box, and I will cover this question in the chat box as I could give more detailed answer if it's possible.
Thank you very much. Okay, the first question we have is, what is a comet?
Comet is a celestial body, and this
a celestial body. Yeah. And the next question asked you is, how does a star die?
The star is collapsed, and
they collapse. Yeah, thank you very much. Next question is that, can a star turn into a planet?
No, a star cannot become planet.
Question is like, why do all the observatories have dome? If you go to the observatory, there's a dome, and inside there is like a telescope. And I'll ask you the different question.
Yeah. I answered in the chat box.
Okay, thank you. Thank you for. So she will be answering all the questions in the chat box here. And we have received many questions. And if you have questions, feel free to type your questions in the chat box, in the Q&A box. All the astronomers and the staff members are trying very hard to answer your questions. And now our astronomers had answered 86 questions. Okay, thank you very much, Tamara. Thank you. And everybody
Welcome.
thank you. Push everybody press the reaction button to send camera. Thank you very much. Next, I'll go to next observatory. We almost come to the end. Next, we will go to Katsupeda, Maratawa, and Sri Lanka. Good evening, Mr. Indica Medagangoda. I'm sorry, I'm pronouncing your name wrong. I'm sorry about that.
Good evening, Hirako-san.
Good evening.
Can you hear me?
Excuse me. Could you tell us where you are and what time it is in your area?
Good evening, Hiroko-san and everyone. And I'm in the ACCIMT Observatory of Arthur C. Clarke Institute, Sri Lanka. This institute, the founder of the institute is, this Arthur C. Clarke. He's the first proposer of the satellites in geostation satellites, and he's the founder of our institute. And we have the main telescope of the observatory is the 45 centimeter Cassegrain type telescope, which was installed in here in 1996, right? So we have been carrying out in very early days, we have been carrying out research, but these days, because of the light pollution and the weather condition changes, we are using this telescope for the educational purposes. And we had the telescope equipped with spectrograph and photometer, and we use this telescope for the astrophotography, and that's depend on the weather patterns. So today now the time in Maratua is 57 minutes past 6. That means 6:57 p.m. So the thing is, the sky is very cloudy because we are in the intermonsoon rainy season. So because of that, so I cannot bring you live coverage of the celestial bodies. So because of that reason, I can show you a couple of events we have captured through the telescope very recently. And so I shall share my presentation now. Is it okay for you, Hiroko-san?
Yeah.
Yeah, sure.
Yeah, we are excited to watch it.
Yeah.
Yeah.
So this is about about our founder, Arthur C. Clarke. He's known for his fiction writer and futurist, and he died in 2008. And he's the first proposer of the geostationary satellites in 1945. And I'm going to present you about a lunar occultation of Saturn, which happened very recently. So what happened is when in this lunar occultation of Saturn is the event where the moon moves in front of Saturn, and the Saturn disappears for a shorter period and reappear again. So in this event, which occurred in a couple of weeks ago, 24 July 25th, and it lasts for 1 hour and 20 minutes, about 1 hour and 20 minutes. So moon is Actually makes a lot of myths in Sri Lanka. So in Sri Lankan culture, the moon introduced as for the little children as and Handamama. Handamama means the uncle of moon. And also Sri Lankan, Sri Lankan has a Buddhist tradition and Buddhist culture as well, and with the other religions as well. Most of the people in Sri Lanka is Buddhist, and especially in full moon days called as full moon poya days, because uh, each full moon day is a poya day marking important religious events in Buddhist calendar. For an example, we say full moon poet day in May. In month of May, we celebrate the Vesak full moon day because it celebrates the birth, enlightenment, and passing away of Buddha, all of which are believed to have occurred on full moon days. So likewise, and there are a lot of myths in about moon and also the sun. In the sun, we called as Indra Devi, or Devi is a god, and likewise so many myths around the moon. So I will show you this uh, video about the occultation. Moon moves towards the in front of the Saturn now, and we captured this under very high, under the cloud disturbances. And now the Saturn going to, yeah, again, it comes after 1 hour and 20 minutes time. So these kind of occultations used to calibrate of the celestial models. Actually, the historical context occultations were key for calibrating celestial navigations, improving the accuracy of astronomical bodies. So apart from that, I can show you another thing we captured through our robotic telescope. This is this is Orion constellation. Everybody, the students know about this. Easily we can identify it in the sky. So, and main two stars, we can find out the Betelgeuse and Rigel, and you can find out easily the belt of the Orion constellation. And here, very important thing, the nebula of Orion. Its nebula is a stellar nursery where the stars are born. So it is a very in this part just below the belt. It's a Orion nebula. Just around the spot of the constellation, and you can see. So I got the image of the constellation like this a couple of period ago. So can see the very clearly about the constellation. The nebula is a cloud of huge cloud of dust and gas. So this is so I can, and you can clearly see the colors of the nebula, red color. This is because of the hydrogen. The hydrogen atoms in the nebula, it ionize because of the very hot and young stars. The light from the very hot young stars, the hydrogen atoms ionize and recombination and makes this beautiful red color. And also the nebula has huge dust particles. Because of that, dust particles scatters the light from the intense light from these hot stars, and makes in blue color, exactly what we see because of the scattering of sunlight. We see our sky is blue. It's exactly the same principle applies here. So this is the Orion Nebula. So this is what I can show you, and also viewers. So what's in the sky right now at the SCCM2 observatory? Let's see. So because I can't give you a live coverage because of cloudy uh, uh, surrounding, and I use this star chart for this, and especially now at the moment, very unfortunately, because Saturn is there right now. This is now the time is 7:05 night. Saturn is there, and also Venus is very close to the horizon at the moment. Right, we can find out these arrows, right? You can see those arrows.
Yes, I can see them.
Yeah,
Yes, I see it.
and also Vega is here, and Deneb is here. So and also Altair, the bright stars, and among of these three bright stars, the Vega has the brightest star at this moment, and makes the summer triangle. And so I can show you the image I just captured last night. Yes. Can you find summer triangle here? Can you find the three
Yes, I
stars?
can.
Vega,
Yes, I can.
yes, Vega, Deneb, and Altair. So I could get some photographs as well. Yes, Vega, Deneb, and Altair. Those three stars make this summer triangle, right? Apart from that, you can easily find out Antares, the brightest star of the Scorpius constellations. It's a red giant star. And also find out the Akshauras in Bootes constellation, also a very high, it's a huge star. Apart from that, I'll show another deep sky object which my staff members captured some times ago. This is deep sky object M16, right? M16 is Eagle Nebula. The again nebula, huge dust and gas cloud known as Eagle Nebula, which stars are born inside the nebula. The nebula is this Eagle Nebula is in the constellation of Serpents and 7,000 light years away from the Earth. And I can show another deep sky object is known as M51. Many of you know about this nebula is known as Whirlpool Galaxy. A spiral galaxy like Milky Way. This is in Canis Venusiti constellation, about 31 million light years away from the Earth, right? So it has diameter of 76 light years, just little smaller than Milky Way. It has exactly 100,000 light years. So those are the things I can show you about the sky in the Arthur Clarke Institute Observatory at the moment. So this is yeah, and also you can see the ecliptic here, ecliptic in the where the suns and the planets, the path of the sun and planet in red in color. You can also see the zodiac constellations like Virgo, Libra, and Scorpion, Sagittarius, Capricornus, and also Aquarius is there where the Saturn is here. Saturn is there, Aquarius, and also Pisces is coming out now. So those are the things if I have a good night sky in just above my observatory, we can see. So this conclude my presentation at the moment. Thank you.
Thank you very much, Indika-san. It was interesting to see the lunar occlusion of Saturn and also hear about what you can see in Sri Lanka. Next, we will go to Q&A. The first question we have is that how does a Saturn get close to the moon?
How Saturn?
How does a Saturn gets close to the moon?
I can understand the question.
So how does a Saturn gets close to the moon?
Yeah.
So
Actually,
we saw the lunar occlusion, so it's
occultation.
about that.
It's not close to because now the moon orbits the Earth, right? So the Saturn and the Earth orbits the Sun. So it's a optical. Actually, it's optical illusion. Like when we see from Earth, so the Saturn and the moon, they have their big distance from Saturn and the moon between them. But when we observe from Earth, we can see moon moves around the while moon moves around its orbit. The Saturn also behind the moon, as we see from the Earth, right? So when Saturn moves around its orbit, we observe the moon moves in front of the Saturn. So it's a kind of optical illusion. That's the moon covers the Saturn light. So it happens occultation.
Thank you very much.
Yeah.
Yes, for explaining that. Okay, the next question is, how do stars move when viewed from a speeding spaceship? How do stars move when viewed from a speeding spaceship?
How does the stars move when someone is going move in the spaceship? Is that the question?
Yes. So someone is on the speeding spaceship, and I think he or she is looking at the star.
Yeah, actually, when someone moves from a spaceship, so he or she can observe stars definitely, but the patterns must be different. So what we observing the on the Earth. So when usually when the spaceship rotates, the direction of the spaceship rotates, the stars moves opposite the direction. Right, this is what we exactly observe from as well. So usually Earth rotates from west to east, right? So the entire celestial sphere, we see it rotates from east to west. Likewise, they can observe the opposite direction of the spaceship.
Okay. So the next question is, what is your favorite, or what is your favorite star or constellation?
Different because my favorite every star is favorite one, every favorite one. So because I think at this moment, right now, I think it's Vega at this moment in the sky. Right now in the sky, Vega is the brightest star, and it is we use Vega has a magnitude of 0.03, and we take Vega as the reference point of magnitude scale. So this is and importantly, so I can say the Vega is the favorite at this moment for me.
Okay, thank you, thank you, Indika-san, and
my pleasure.
Thank you very much. Everyone, please push your reaction button to thank Indika-san. Thank you very much. So today we broadcasted from 7 observatory. So it's almost the end of our event. We broadcasted from observatory all over the world. We learned the stars and constellations appear in the sky depending on the latitude and longitude. Now we want you to see the stars and constellations in your area and realize the differences in the stars you saw today compared to other parts of the world. Now, we would like to ask Dr. Rebecca Allen for the closing remark. Dr. Rebecca Allen is a co-chair of the SC4O Working Group and the co-director of the Space Technology and Industry Institute at Swinburne University of Technology. Please welcome Dr. Rebecca Allen.
Good evening, everyone. And for some of you in Hawaii, it is very early in the morning. So thank you so much for joining us tonight for our APRSAF Stargazing party. I'm joining you from Melbourne, Australia, which is also on the lands of the Wurundjeri people of the Kulin Nation. And I would like to pay my respects to their elders, past, present, and emerging. Indigenous astronomy and cosmology is very important, and the indigenous astronomy of Australia goes back tens of thousands of years. And we've heard so many wonderful stories about the constellations tonight and their meanings. And actually, my favorite story is of the Seven Sisters. And we saw very first from Hawaii, the constellation Subaru, which is part of the indigenous cosmology in Australia, is known as the Seven Sisters. And what this shows us is the connection between the people and the land and the seas, but also with the sky, and how important it is for us to all be custodians of this important area, this night sky, which allows us to see these beautiful stars and galaxies and appreciate the stories and their link to our culture. And so I wanted to say that especially because this year for APRSAF, we're thinking about sustainability in space and how we can all come together from wherever we are to collaborate to have a more sustainable activity in space. So today especially is a great example of this because as Ms. Hiroko mentioned, we're joined from observatories going as far north as Azerbaijan and the northern latitudes, 40 degrees, all the way down to Melbourne. I think I can claim the farthest south latitude of negative 38 degrees. And as we mentioned, the stars look different depending on where you are on latitudes. And so it's amazing because we got to hear some great stories about all of the different constellations and the skies that we see from these observatories across this region. So I wanted to end by saying thank you all so much for joining us tonight. And you can see that even though the stars might look slightly different, as we know from these stories and our culture and how much we love the night sky, that it truly connects us all. And it's so exciting to get to share this fun and inspiring activity with you all tonight. So with that, I would especially like to thank my co-chair, Mr. Fumiaki Tanigaki, my co-chair for the APRSAF Space Education for All Working Group, and Ms. Hiroko and the team for putting on such an amazing virtual stargazing event for us tonight. So thank you all so much for joining us. And again, like we mentioned, please go out in the night sky and look at the moon and the stars if you have a telescope. I hope we found some interesting objects for you to look at in your own time. So thank you so much. Back to you, Ms. Hiroko.
Thank you very much, Dr. Rebecca Allen. Thank you everyone for attending this Stargazing event. After you close this webinar, our questionnaire will show up. Your opinions are very valuable. We will upload a recording of this event later on the JAXA Space Education Center YouTube channel. So bye-bye, everyone. We hope to see you again someday in the future. Thank you very much.